Hi, welcome to Mat140, and we're going to discuss today 12.1 counting methods. And we're going to talk in this chapter 12, about arrangements of different objects, trying to count these objects, trying to set up an idea. So, the first thing we want to do is figure out how many ways we can do something. And let's start out with something simple. How many ways it would take to flip a coin? How many outcomes could you have? In other words, sometimes ways and outcomes mean pretty much the same thing. How many outcomes would you have if you flipped a coin? Well, you'd have two, huh? Heads or tails. So basically, there's two outcomes. And that's what we're trying to determine, how many outcomes there are. And that's what we mean by counting. We could count that there's two different ways to do this, either heads or tails. What if you roll just one die? You have a pair of dice, but you just roll one of them. And how many outcomes are there? Well, there's six, huh? You could have the number one, the number two, the number three could come up, number four could come up, five or six. So there's 1, 2, 3, 4, 5, 6 different outcomes, or six different ways that it could come up. Okay, what if you picked a card from a deck of cards? How many cards are in the deck? There's 52 cards in the deck. So there's 52 different ways that the numbers that could come up, or letters, or not letters, but pictures or whatever. So there's 52 outcomes that could happen if you just picked one card at random. What if you wanted to name somebody? There's 5 people out there and you want to name one of them as a president. How many ways could you do that? Well, there's 5 people, so there's 5 different ways it could happen. 5 outcomes. So that's what we're going to kind of discuss in this chapter right here. How many outcomes? We can do it different ways. Sometimes if the numbers are small enough, we can just list them. But if the numbers are pretty big, then it's a little harder. Okay, so I'm going to take one here. Let's say we have 4 guys and they're trying out for the basketball team, but we can only pick 2 of them. There's only 2 slots left. There's Albert and there's Barry. And I'm just going to list their first initials. And there's Chris and there's David. So there's 4 different people trying out for this team, but we can only take 2 of them. Let's see if we could list all the possible ways that could happen. Now, when we do this, we're going to say order is not important. Let's do it one way. Let's just write it up here. Order is not important. Like when you're watching Dancing with the Stars, import 10, import. I'm trying to do 2 things at the same time. Sorry. Order is not important. When you watch Dancing with the Stars at the end, it says these people have been picked, and the order isn't important. How they picked them, they just are reading them off randomly. Okay, so order is not important. In other words, if we picked A and then we picked B, or we pick B and then A, that would be okay. That's the same thing. Okay, order is not important. Either A is picked and then, or B was picked first and then A. So how many ways can we do this? Well, we could pick A and B, and then A and C. Sometimes it's hard to do, and then A and D, huh? Or we could switch them around. We could pick C first and then A, D first, then A. What other combinations could we have? Well, we could pick B and C. I don't think I've written that one down yet. Or B and D. See how I'm doing this? I'm picking this B and C and then B and D. And I could pick the reverse of that. D, and B. And finally, I think we could pick C and D, or D and C. So if order is not important, we got 1, 2, 3, 4, 5, 6, 12. 12 ways that these guys could be picked. We could have picked Albert first and then Barry first and then Albert. So there were 12 different ways that we could have picked these guys for there's only 2 positions. Okay, now, what if order was important? Order is important. That means once we pick one of them, he cannot be picked again. So we could have picked A and B. We could have picked, but we can't pick B and A. We just have to pick, once we picked them in that order, they're picked. We could have picked A and B. We could have picked A and C. Or we could have picked A and D. We could have picked always Albert first, and then these other guys second. Or maybe Albert didn't get picked at all. We could have picked B and C and B and D. Or we could have just picked C and D. You see, it would have been just this row right here when the order is not important, is important, then we couldn't do these repetitions here. So it would have been just 6 ways. Okay? Now, what if they said there's 6 slots and it just doesn't work out so great with picking basketball players, but you could pick the guy more than once. Like you could have said, well, I'm going to pick him. Maybe a couple coaches are picking and they both pick the same guy. So if order is not important, but we can use repetition. Repetition means we can use the letter more than once. So I'm just going to add it here, and I'm going to put with repetition. Repetition. If we are allowed to use repetition, order is not important, but with repetition, that means we could have picked A twice, B twice, C twice, and D twice. That would have upped our total from 12 to 16. And the same thing could happen here. Order is important, but we could use with repetition. So if they say we can use repetition, then we could also use AA, BB, CC, DD. So we get 4 more. So that ups this total from 6 to 10. So we have different ways of saying order not important. Order is not important with repetition. That gives us more choices. Order is important, gives us kind of less choices. Order is important with repetition. So it is a little confusing when you first see it. Okay. The other thing they kind of show in the book is a tree diagram. Let's suppose we're flipping a coin, and it says, in how many ways can 3 coins be flipped? In how many different ways can 3 coins be flipped? Okay, so let's see how they do it. We could flip the first coin, and we can get say we do the flip. Could be heads or tails, right? 2 choices. Okay. So we're not doing, in how many ways can 3 coins be flipped? I think we're actually doing flipping the coins 3 times is what happens. We have 1 coin, but we're flipping it 3 times. So the first time it could come up heads. The next time it could come up heads or heads and tails. I mean, you could think of it as 3 different coins, but you can also have, this would come up heads or tails, and this one would come up heads or tails. So in the first flip, you could get a head, or a head and a tail, or a tail and a head, or a tail and a tail. And then on the third flip, so you could get head, 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 tail, tail, head, tail, tail, head, tail, head, head, tail, tail. And you could have tail, head, head, tail, head, tail, tail, head, tail. Excuse me. Tail, tail, head, tail, tail, tail. There we go. We can also do this something by what we call the slot method. The first time you flip the coin, there are only two combinations. The second time you flip the coin, there's still only two combinations, heads or tails. Third time you flip the coin, there's really only two combinations, heads or tails. But if we multiply these together, we get a total of 8. 1, 2, 3, 4, 5, 6, 7, 8. So I sometimes call this the slot method. We just fill in the slot. Sometimes we can do that, especially if we have a lot of numbers we want to fill in. Sometimes using slots is a lot easier. Okay, let's suppose we're rolling some dice. Okay, we have 2 dice. How many combinations do you think we can get if we roll 2 dice? We're a pair of dice. Well, on the first dice, there's 6 different numbers that could come up. And on the second die, there's 6 different numbers that could come up. So there's a total of 36 ways that 2 dice could come up. The combinations, like you could have a 1 and a 1, and a 1 and a 2, or a 1 and a 3, and so on. And if you labeled them all, you'd have those combinations. So if you look in the book, if you have your textbook, on page what is that, 624, they list all the different combinations. Now notice there's something important here. Right here, when you use, say we were rolling 2 different colors, a red dice and a green dice, we could have a red come up 2 and 1, and then the green come up 1 and 2. So red was 2, green was 1, red was 1, and green was 2. But here, when you roll the same numbers, that's only considered as one choice. Okay, that's not considered 2 choices. That's just, it either comes up red was 1 and green was 1. If you switch them around, green is 1 and red is 1. It's the same thing. Here it would be different. Green 2, red 1. Green 1, red 2. So that's a different choice. So altogether, there's 36 different combinations. Well, let's say we wanted to roll the number 7. We wanted to roll a 7. How many combinations are there that would make 7? Let's list them. You could have a 1 and a 6, right? That would make a 7. Or you could have a 6. Let's call this the red dice and this the green dice. You could have a 6 and a 1. You could have a 2 and a 5, or 5 and a 2. Remember, these have to add up to 7. I've done this before, and people are saying, how about a 3 and a 5? No, that doesn't make 7. Okay. What about a 3 and a 4, though? And a 4 and a 3. Are there any other combinations? Well, we used 1s, we used 2s, we used 3s, we used 4s, we used 5s, and we used 6s. So I don't think there's any other combinations. So how many combinations out of these 36 add up to 7? Only 6 combinations. Out of all these combinations, there's only 6 that will add up to 7. The 6 and 1, the 5 and 2, the 2 and 5, the 1 and 6. So we could go over here, see, 1 and 6, 2 and 5. So Altogether, you could go through there and you find there's only 6 combinations. What if we wanted to row the number 8? We want to try to row the 8. So here we probably have to list them. There is no really shortcut to figuring it out. To row an 8, let's start out with a small number. Could you use a 1 and a 7? No, because there's not 7 on a, there's only 6 numbers on a dice. So you couldn't use 1 and 7. You can't use 1 at all. You could start with a 2 and a what? 6? And we could reverse it 6 and 2, huh? Red, green. Maybe I should put it underneath. 6, 2. So the red. How about 3 and 5? 3 and 5, 5 and 3. These are like just little dashes here. Any other combinations? A 4. 4 red, 4 green, but if we reverse them, it's still 4 green and 4 red. So we only write it down once. So to row an 8, there's only 5 ways you can do it. There's only 5. You might have thought, well, out of 36, there'd be like 18 different ways you could do it. No, there's only 5 different ways that you can row an 8. Surprising, huh? You would think there would be a lot more combinations. So that's the only combinations that could come up. So that's how we kind of look at those kind of things. Let me look at something here real quick. Okay. So when we're trying to, now let me make one a little bit harder. How many combinations are there to row a number greater than 8? Greater than 8. Okay, how many ways can we row it? Row a number, how many ways? Row a number greater than 8. Could we row an 8? No, it has to be greater than 8. So the only numbers we can row are a 9, a 10, an 11, and a 12. So let's see the combinations that make a 9. Can we use a 6? Yes, 6 and 3. And we can reverse that. Remember, we're using 2 different colored dice. So we could use 3 and 6. Even if they were the same color, we still reverse them. 3 and 6. What else? Could we use a 5? Yeah, 5 and 4, 4 and 5. Could we use a 2? No, because 2 and 7, but we don't have a 7. So there's actually only 4 ways to row a 9. That's hard to believe, huh? What about rowing a 10? A 6 and a 4, 4 and a 6. And notice I always start out with the biggest dice. And a 5 and a 5. What about a 3? No. 3 and 7, that won't help us. So there's only 3 ways to row a 10. How about an 11? 6 and 5, 5 and 6. 4 and 7 won't work. 2 ways. And how about a 12? 6 and 6. And no other combination. There's only 1 way to row the number 12. So how many ways are there to row a number greater than 8? 4 plus 3 plus 2 plus 1. 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. There's 10 ways that you can row a number that's greater than 8. 10 out of the 36. So you might have some exercises like this on the quiz. How to row a 7 or an 8 or a specific number, and then maybe numbers that are greater or less than a certain number. But if it says greater than 8, it means greater than 8. It means 9, 10, 11, and 12. It doesn't mean 8 also. Okay, so you have to take the time to actually list them, to think them out sometimes. Remember, there's only 36 combinations altogether. Okay, now sometimes we have a lot of stuff that we have to combine. So in the book, it shows sometimes we have a lot of outfits that we want to put together. Suppose you had, um, it says you're looking to get a new outfit. So there's 5 tops that you can pick that you have, and you got 4 pairs of pants. You have 3 jackets. You're kind of thinking to dress up for work, and you have this kind of clothing in your closet, and you're thinking, how many combinations could I make out of those? How many different ways could I arrange those? Well, we use a little technique. Again, it's the slot method. There's 5 tops, there's 4 pants, and there's 3 jackets. And if we multiply all those together, you have 60 different combinations you could come up with. That's hard to believe, huh? That you would have 60 different combinations. Sometimes we do this with outfits or with arranging different things. Maybe you're painting a bookcase and you want to paint the shelves different colors and so on. And you could even paint them the same colors if you wanted to. And you had 5 different paints, 5 blues, 4 reds, and 3 oranges, and you wanted to combine them. Again, there would be 60 different ways that you could combine them. So this is sometimes what we do. We, instead of listing them, that would be a lot of different ways to list. We can't list them all, so we kind of write them that way. One last thing I'll try with you. Let's suppose we had the numbers 2, 3, 4, 5, 6. We have these digits. We call them digits. And we wanted to arrange them so that there's, we can only pick 2 of the digits. 2 digits out of this group. And we want to figure out how many different arrangements we can make without actually writing all the arrangements down. Well, how many digits do we have altogether? 1, 2, 3, 4, 5. We have 5 digits here. So we could pick any number here in the first slot. But once we pick, say we pick 2, the number 2, how many digits are left to go in the next slot? There's 4 to pick from. So altogether, there's 20 ways that we could arrange these. It's hard to believe. We could put 2 with 3, 2 with 4, 2 with 5, 2 with 6, and you could list them all, but you find out that there's 20 different ways to list these. And that's why math guys come up with faster ways to do it. Now, what if that's using these digits without repeating? What if we could repeat with repetition? What if we could repeat them? Well, then there would be, if we wanted to put a 2 and then another 2, there would be 5 ways to do this one and then 5 ways to do the other one. So it gives us extra choices, and so there would be 25 different ways. So without repetition, there's 5 numbers that you could put into this first slot. But once you pick one of them, it doesn't matter which one you pick, there's only 4 left for the next slot. See? First there were 5, now there's only 4. And so that's the way it works. So you can kind of use this technique also and you want to try some of these problems on 626, 1 through 20, and then 31 and 32. See if you can do those problems there. Counting license plates. Let's try 31. It says an eyewitness to a crime said that the license plate of a getaway car had the letters TXL, but he could not remember the order. The rest of the plate had the numbers 834, but again, he could not recall the order. How many different license plates must the police investigate? Okay, so apparently there's 6 different combinations. And apparently the guy realized that these were not repeated, right? So there were three choices. I guess the letters came first. There are three possibilities here, two possibilities here, because now we used up two of the letters, and now there's only one letter left to put in here. Okay, on the numbers, there aren't 8 numbers to put in here. There's only 3 numbers we get to pick. 3 digits, 8, 3, and 4. So there's only a total of 3 digits. You don't want to put an 8 here. There's only 3 digits to pick from. Once we pick, say, the number 8, there's only 2 digits left. And once we pick this, there's only 1 digit left. So if we multiply all these together, this should tell us the total number of combinations. These are for the letters, and these are for the numbers. And 3 times 2 is 6, times 1 is 6, times 3 is 18, times 2 is 36, times 1 is 1. Or you can multiply them in any order. There's 36 different ways or combinations or arrangements, which is called 36 different arrangements that we can make. So they could track it down by trying each one of those. There's 36 different ways that they could try to track it down because he didn't know. You would think you would remember the first letter, but he didn't. Okay, so there's 3 to pick from here. But sometimes people get confused with numbers because you think, oh, okay, there's 5, there's 8, the number 8 goes in here. No, there's only 3 numbers to pick from, or 3 digits. So you can only put either the 8 or the 3 or the 4 in this position. Once you use the 8, you can either put 3 or 4 in here. See, now you got 2. Once you pick the 3, there's only one more number that can go in here. So here you had 8, 3, or 4. Here you had either 3 or 4. And here you finally had 4. So it kind of gives you the idea that there's only one left. Okay. Same thing here. You could put in a T, X, or an L. But if you pick the L, then there's only T or X to choose from. And if you pick the X, there's only T that could go in there. So think about it. It's just kind of a new way of thinking about different things in this chapter. Hope you enjoyed it. This is going to be kind of one of those logic things. So.